second job. I worked with Marie.
They need jobs too, man.
Can you check my my record? If I have any.
Just Google your own name. Your name is so uniquely spelled, I bet you won't get
One
many.
got high, like, one shot up, heroin in his car.
No, your name is great.
One break, and then he came back in and he passed out in the store.
Okay. Refocus. We gotta go, we gotta go. Okay, look at your green sheet. So, look at number 1. You have a giant chart of fun. Okay, it says your functions are differentiable. All that differentiable means is that their graphs don't have any cusps, corners, breaks in the graph. Okay, and then also no vertical tangents. So that just means every x, you can take the derivative. Now, we can't take the derivative for every x if we don't have it in the table. But it's just saying that all your functions are like regular, normal, maybe like a polynomial or something like that. Okay, so take a look at number 1. Okay, this is really common on the AP test. So it says, find h prime of 1 given that h of x is 3f of x. Okay, so you're going to do this in 2 steps. If I have h, I want h prime. So I'm going to find h prime of x. Then I'm going to find h prime of 1. The first thing I want you to do is label both of those guys. Some of you are still not labeling stuff on your quizzes. So look at your h of x. It's f of 3x. Okay, f of 3x. Remember yesterday we learned you take the derivative of the outside function first. What's the derivative of f called?
F prime.
And then in the middle, what do you keep?
3x.
3x. But then you times by the derivative of the middle, which is 3x derivative is times 3. Yes?
Is this anything related to yesterday?
It's an extension. Yeah, we're just doing like tables and parallels and stuff. Okay, so from here, I want h prime of 1. Then I'm going to find f prime of 3 times 1, and then I'm going to multiply that by 3. Now, keep in mind, okay, that's a PEMDAS type thing, so you're going to have to find that number in the middle first. So if it's 3 times 1, that's really a 3. What's f prime of 3 in the chart? F prime, 3, it's a 2. 2 times 3 is 6. Make sense? Okay, one right next to it. Take a look at letter B. Okay, I want h prime of 2. Given h of x equals this, well then I'm going to find h prime of x, then I'm going to find h prime of 2. Now, for my h prime of x, what is the outside function if this is my function right here?
X squared.
F. The core is x squared minus 4. So when I take the derivative of f, it's going to be f prime with the same core. But then I have to multiply by the derivative of the core. What's the core in here?
2x.
2x. Now, some of you guys on your quiz that I surprised you with on Friday, okay, forgot that when you plug x in, you need to plug 2 into both of those x's. So I'm going to have f prime of 2 squared minus 4, and then a 2 times 2. So you need to plug that value in for every x that you see. And then remember, you work your way inside out. So if this is 2 squared minus 4, that's really what? 0. So that's f prime of 0 times, and then 2 times 2 is 4. And then what's f prime of 0 for me from my chart? Okay, 0's here, f prime is a half. Then I want half of 4, which is 2. Make sense? Okay, next one. We want h prime of 2. H is g of 2x. So we want h prime of x. Then we want h prime of 2. Okay, g of 2x. What's the derivative of that going to be? G prime of 2x times 2. And you're pulling, remember, the extra u prime out at the end. Then from there, when I plug a 2 in, what is my number here in the center now? 2 times 2 is going to be g prime of 4. And then I'll find that value from my chart. Then I'll multiply it by 2 because of the chain rule. So what is g prime of 4 up here? 4 g prime is a third. Times that by 2. A third times 2 is 2/3. Good? Okay, try letter D. You want h prime of 0. H is g of 4 sine x. I'm going to find h prime of x, then I'm going to find h prime of 0. Okay, what is the derivative of g 4 sine x? G prime, what happens to the core? Stays the same. So your 4 sine x in the middle should be identical to what it was before, but now we'll times by its derivative. So if it's a 4 sine x, what's the derivative of that? 4 cosine x. Very good. Okay, and then notice after I take the derivative, that's where I'm plugging in 0. So in the middle here, I have g prime of 4 sine 0 times 4 cosine 0. Remember, you are plugging your x value in for every single x across the equation. Okay, in the middle, what's the sign of 0 here? 0 times 4 is still 0, so I want g prime of 0. Then I'm going to multiply that by 4 cosine 0, but what's cosine 0? And 4 times 1 is 4. Then look at your chart. What's g prime of 0? Okay, g prime of 0 is 5. So 4 times 5 is 20. Make sense? Okay, next row, we want to write the equation of a tangent line. What two pieces do you need for an equation of a tangent line? Point and a slope. For the point, where do I plug in? The original. Okay, and then for the slope, I plug into the derivative. Okay, so take a look at number 2. We're plugging in 0. Point first. My x value I already know is 0 because it told me. My y value is going to be h of 0. Well, that's cosine 0 times g of 2 times 0. And then remember, you're going inside out. So cosine of 0, what do I get here? 1. And then 2 times 0 in here, what do I get? Then I just want g of 0, not g prime, regular g. So look at your chart. At 0, what is g of 0? -3. So I'd have 1 times -3, which is -3. Okay, we have our point. After we find our point, we need our slope, which means we're taking a derivative. Now you have several rules you have to pick between. So if my function is cosine x g of 2x, what's my rule going to be that I'm going to need? Product rule. Very good. So, product rule. My u is going to be cosine x. My v is going to be g of 2x. However, when I take the derivative, what rule am I also going to use now? Chain rule. And where am I going to use it? U or v? Which one has chain in it? V. U is cosine. What's the derivative of cosine? Negative sign. So no chain rule there. But when I get to my g of 2x, that's going to need chain rule. So v prime would be the derivative of g of 2x. Well, that would be g prime of 2x times 2. Now, is it okay if I just start writing the 2 in the front? Well, with you, I meant. Yes, it's okay. It's the same, right? So you can times it at the beginning or the end. Okay, from there, if this is h, what do I label the derivative? H prime. So sassy. Okay, so that would be one diagonal plus the other. I'm going to do this one first, but remember, really, it doesn't matter. So I have cosine x times 2g prime of 2x plus, for product rule in the middle. And then my other diagonal is g of 2x times negative sine x. And you want to be really careful about making sure that you're labeling clearly whether it's a prime or a regular, because when I plug in, I don't want to be confused, right? Okay, so from here, we are finding h prime of 0. What is the cosine of 0 for that first term? Okay, that's a 1 times 2. And then what is 0 if I plug it to the inside here? Still a 0. Now look at your chart. What's G prime on the 0 row? 5. So 1 times 2 times 5 plus, that's going to be a 10. Okay, then for my next term, I have a negative sine 0, but what's the sine of 0? Still 0. And if I multiply 0 by G, that whole term is going to basically go away. So 1 times 2 times 5 is 10, and I'm ready to write the equation of my tangent line. Make sense? Okay, from there, my equation would be?
Y plus 3
Yep.
equals 10 x minus 2.
Perfect. Got it? No, you can leave the 0 off altogether if you wanted. It won't really make a difference. Okay, take a look at number 3. Okay, we want to write the equation of the tangent line. What are you going to do first? Point. What's the x value? 1 comma something. Then I want h of 1, which is the y value at 1. So I'm plugging that into my original, which is f of 1 times g of 3 times 1. Okay, then remember, it's inside out for composition. So I'm going to times the 3 and the 1. That's going to stay a g of 3. And then when I look at my chart, I need to make sure regular f, regular g. We're not doing primes. What's f of 1?
3.
What's g of 1? Or I'm sorry, g of 3? 0. So then that's going to be 3 times 0, which is 0 for my y value. Okay, from there we need our slope. We're going to have to choose a rule. What rule will we choose for number 3? Product rule again. My u is going to be f of x. My v is g of 3x. Which of those is going to need a chain rule in it? Just v. U prime is going to be fine. So, for u, if it's f of x, what's the derivative of that? Good. Now, real quick, let's talk about, someone was saying, how do I know when to do chain rule and when not to? They didn't talk like that, but pretend. How do I know? Okay, if this was a chain rule, what's the derivative of x? 1. You want to do chain rule on it, you can. It just doesn't change anything. Really, every derivative technically is a chain rule. But if it's just an x in the middle, your derivative is a times 1, you're basically skipping it. So there's no non-chain rule derivatives technically. But if your middle's an x, that's why you don't really have to consider it a chain rule. Okay? Alright, so v prime, derivative of g3x is g prime 3x times 3. And I'm going to put the 3 in the front. You can put it wherever you want though. Okay, my original was called h. My derivative will be called h prime. So I'm going to do one diagonal plus the other. I'll do this guy first. So I have f of x times 3g prime of 3x plus then f prime of x times regular g of 3x. Okay, then from there we're plugging in our value. Our x value is a 1. So I want h prime of 1. So I'm going to have f of 1 for this first spot times 3 times g prime of, what will be in the middle here if I plug in a 1? Still a 3. So just be careful about that. Don't just start popping in 1s. If there's a 3 in there too, you got to times them. Okay, then that'll be f prime of 1 times g of 3. Then from there, we're checking our table, pulling all those values out. What is regular f of 1? 3 times another 3 here. What is g prime of 3?
3.
G prime of 3 is another 3. Plus, what is f prime of 1? 1. And then what's regular g of 3? 0. So that guy crosses out. 3 times 3 times 3 gives me 27. Then from there, I have my point, I have my slope, I have enough information to write the equation of my tangent line. So it'll be y minus 0, 27, x minus 1. Easy? No? Okay, last one, number 4. Find your y value. So my x is a 3 for my point. Then I want h of 3. So I want f of 3. And then I'm going to take that value and I'm going to raise it to the 4th power. Now this is where you have to remember, compositions, you're starting on the inside. So I need to find this guy, then I'll raise that to the 4th power. So what is f of 3? Negative 2. So I want negative 2 to the 4th power. Okay, well what's negative 2 squared? 4. And another negative 2 squared is another 4. Times those together, what do you get? 16. Positive 16. Very good. Even exponents, the negative crosses out. Okay, from there, I need to find the slope, which means I need to take a what? Derivative. What rule are you using this time? Composition, which is called the chain rule. So, what is the core of f of x to the 4th? Okay, the core of that would be f of x. So my middle is going to stay an f of x. But I'm going to do power rule around it. So my exponent of 4, that's going to pop down here to the front. So I'm going to have a 4 here. Then what's my new exponent? Oh, oops.
3 is the new exponent.
Tricked them. And then 3 is the new exponent. Okay, and then am I done? What's the derivative of the middle? F of x derivative is f prime of x. So I bring that top number down, I change the power, then I times by the derivative of the core, which is f at the back, which is f prime. Okay, from there we are plugging in 3. So I want h prime of 3. Well, then I want 4 times f of 3 cubed times f prime of 3. And this is where you have to just kind of go at your own pace, look at the table. Okay, what is f of 3 here in the middle? F of 3 is negative 2. We found that before. So I have 4 times negative 2 cubed. And then what is f prime of 3? 2. Okay. Then from there, okay, what do I do next? PEMDAS. What comes first? Exponent. Negative 2 cubed is? Negative 8. What is 4 times negative 8? Negative 32 times 2? Negative 64. Then from there I have my point and my slope. That means I can write the equation of my tangent line. So it'll be y minus 16. Negative 64 is my slope. X minus 3. Good?
We are so good.
You guys are so good. Any questions? I love to help. Make sense? Okay, alright, flip over the back. Okay, did I tell you all to get a calculator? Okay, will you grab one? We can check one out to you.
Huh?
Did you say, what if you can't afford one? Oh, I thought that was what you said. What did you say?
I said, are you gonna record this?
Oh, I already am, yeah.
Oh. I record everything I do.
Good.
Just to make sure I remember.
Good. Okay, take a look at number 6. I want them to be parallel. What do I do? Okay, parallel means same slope. And same slope means I set what equal? So I'm going to set f prime of x equal to y prime. Y'all did actually pretty well on this on your quiz. Okay, if f of x is sine x, what's the derivative? Okay, f prime of x, derivative of sine is cosine x. Then I look at my line, that's not going to work, it's all messed up. So we're going to have to solve it for y equals. So if it's 3y minus x equals 12. Okay, I'm just pulling my equation from here. I'm going to have to get y by itself. What would I do first? Okay, bring the x across. Now it's an x plus 12, then divide by 3. So I have y equals, yep, I'm going to put 1/3 x. That's the same as x over 3 though, and then plus 4. Now remember, that's useful for my y, but I need my y prime. So if that's y, what's y prime?
4/3.
What? 1/3, yeah. Because 4 is a constant. So the derivative of the constant just goes away. Okay, now from here, what am I doing with these guys? Okay, you need to set them equal on your paper, but you'll solve it in the calculator. So I'm going to let cosine x equal 1/3, and then I'm going to use the calculator to solve. Okay, so you should still be writing pretty much every step until that one step. Now, how do you solve that in the calculator?
Cosine x and y1.
y1, y2, look for where they cross. Could you also inverse cosine? Sure. If you want to get fancy, you could easily solve it like that. It would still be right. Okay, so you're typing in y1 and y2. Okay, type them in, and then what window am I looking at? Because remember, cosine's going to cross that over and over and over again. What window are we looking at? What domain?
0 and pi.
Only 0 to pi. Remember, cosine's going to cross it over and over again. So I'm typing my cosine in as y1. Typing 1/3 in as y2. And then I'm also going to restrict my window, so hit window right here. And I'm going to go only from 0 to pi, just so that I don't have to find all the extra intersections, since we don't really care. Okay, there's cosine, starts at 1. There's my flat line at 1/3. You remember how to find where they cross?
Intersect.
Yup, second trace, intersect, and then enter, enter, enter. So they crossed at 1.2389. Remember, AP test, you're going to 4 decimals. 1.2309. Good? Easy? Okay, next one. We want to know where these equations are parallel. What are we doing? Taking the derivatives, setting them equal. What are both of these equations going to need, though? Neither of them are a line anymore. Neither of them are lines anymore. What rule are you going to need? Chain rule on both. Okay, you're going to need chain rule here. You're going to need chain rule here. So, take the derivative of both of those guys. We'll check them in a second. You're taking the derivative of y equals e to the 2x and y equals 2, 3x minus 2 cubed. E to the 2x times 2, that's correct. Yes? Sure. Okay, then for my other guy, what's my core? Okay, 3x minus 2, but then I need to do power rule around it. So I'm going to take my exponent of 3, I'm going to times it down on the 2 in the front. What am I going to get then? 3 times 2 is a 6, then it's squared, times. And then the derivative of the middle is a times 3. Then from there, remember, typically they're going to pull those constants together. 6 times 3 is really 18. So I have 2e to the 2x equal to 18 3x minus 2 squared. Okay, then you're putting both of those into your equation. This one you're going to put as y1. This one you're going to put as y2. And then look to see how many times they cross. Now, when I read that, I see values of x. So it's probably going to cross twice.
Yeah.
It does?
Yeah, because it's a parabola.
Yes.
How do you know that?
Okay, now when I hit graph, my thing is all messed up from when I shrunk it. So do you know how to fix it? Easy, hit zoom 6 and it'll regular zoom you. So I'm going to push zoom here. Actually, I mean, I can almost really see it anyway, but oh well. Zoom, and then go down to standard number 6. And then it'll fix your window to where you don't have to have it zoomed weird anymore. Okay, there's my exponential. There's my quadratic. Then I'm going to do second trace. 5, enter. Okay, first one I found is x equals 0.4860, and then I need to find my second guy, second trace, option 5, enter, and then for guess, I'm going to like scooch over closer to the other one. So you can just kind of arrow over to the other side. So 3.0769. Make sense? Easy?
Yes.
Okay, next one. Oh, I haven't given you the derivative of secant x yet. Write in your notes, do you have them out? The derivative, wow, of secant u. The derivative of secant u is going to be secant u tan u prime. Should we find it by hand?
Yes.
Let's do it.
No.
Oh. Okay, what is secant the same as? No. 1 over cosine, right? So, this is just for fun. You can put your pencils down and just be amazed. Okay, so this is really the derivative of 1 over cosine, yeah? Okay, I'm going to make all my other classes prove it. I forgot about this. Okay, so from here, cosine x is on the bottom. That means I can write it as cosine x to the what power? Negative 1, right? Okay, from here, what do I do for the derivative? I times the negative 1 down. So I have a negative here. Negative 1, then what is the power on cosine x if I take away 1 more? Negative 2. Then I multiply by the derivative of the middle. What's the derivative of cosine? Negative sine x. What's going to happen when I have a negative here and a negative here? Cancel out. So really what I'm left with is going to be sine x over cosine squared x. Yeah? So far so good? Okay, because these guys have a negative exponent, so they go on the bottom. From there, look what I can do. It's a 1 over cosine x times a sine over cosine x. And what's 1 over cosine? And what's sine over cosine? Yeah. Now, keep in mind that this is like if it's not a chain rule, right? So since it is a chain rule, when I use my rule, I'm going to need to make sure to times by the derivative of the middle. So this is just a fun proof.
Fun.
Yep.
No.
Okay, a little fun proof for you. But from now on, this is a rule that you're supposed to know. Okay, so let's review. What's the derivative of tan? Secant squared. What's the derivative of secant? Secant tan. Yeah? Derivative of secant is secant tan. So now you know sine, cosine, tangent, and secant. Okay? Alright, from here, we're taking the derivatives, we're setting them parallel. So if my first function is secant 2x, what will f prime of x be? Okay, what's my u in that case? What's my core? 2x. So I'm following my rule here. The derivative of secant u tan u is now going to be secant 2x tan 2x, but then times what? What's the derivative of my core? Times 2. Okay, my other equation, g of x, was tan x. Right here, put a g in front. Okay, so if g of x is tan x, what's g prime? If g is tan x, what's g prime? Secant squared x. Very good. Now, from there, did this one require chain rule? No, because the derivative, the core is x, so the derivative of that is just a times 1. That's why you don't have to put it. Okay, from here, if I want them to be parallel, what am I doing with those derivatives? Setting them equal where? On your paper, and then solve in the calculator. But you got to do both. It has to be on your paper and solved. Now, try to figure out how to put that in the calculator, okay? Think, what could you do? So secant 2x tan 2x times 2 equals secant squared x. So that's my equation right there. How would you put that in the calculator? What would you have to do for the secant?
Divide.
Yes, yes. You'd have to open a fraction. So you'd put alpha y equals n over d, pull up your fraction bar, and then when I want secant 2x, I have to put 1 over cosine 2x, yeah? Okay, and then times tan x. Okay, so I'm entering the left side, which doesn't have the square, but when I get to the right side, yes, I will have to square. So I have secant 2x is 1 over cosine 2x. Then I have a tan 2x, and then times a what? 2. So that's my y1. Now for my y2, I need a secant squared. Well, then I would open the parentheses first. Then do the alpha y equals 1 over cosine x. Okay, that's serving as your secant down there. And then you're going to have to square the whole thing. Got it? So the secants can be a little bit annoying to type into the calculator. You may want to write on your sheet if you're afraid that you're going to forget. Okay, but remember, secant you can only put in the calculator as a 1 over cosine. And there may be a shortcut for it. If you ever find it, let me know. Okay, that'd be great. All right, now from here, what are we doing? Taking the equations, setting them equal. Now, anytime it's a trig, you're going to need to restrict your domain because these are going to probably cross a bunch of times. So look right here, we're only looking here. So I'm going to go into window and I'm going to adjust it. So that's going to be negative pi over 4 and then positive pi over 4. Okay? So from negative 0.78 to positive 0.78. And then the other scales I don't really care about. You could adjust them if you wanted to though. So there's our first graph. That's our secant tan. Okay, coming in extremely slowly. Okay, then our other graph is going to come in next. We're looking for where they cross. Okay?
Whoa.
Yep.
Hit the whoa real quick. Hit the whoa. Ooh! That was so awesome.
I had to stick my tongue out to do it correctly, you know. Alright, you got it? Then second trace, number 5. Enter, enter, enter. Have y'all seen the weatherman do the whoa? Y'all know who I'm talking about? I'll have to show you if you haven't seen it. Huh?
I thought that guy was on E.
Yeah, I think he's like on the North Carolina news. He's my future husband. That's all I have to say. Got it?
Yikes.
No, no yikes. 2, 2, 1, 5. Okay? Alright, we have 46, 50. Oh yeah, we got time for the last one. Okay, what does mean value theorem say? Okay, what type of function does it have to be? Continuous and differentiable. Okay, now keep in mind that if it's a cubic, we already know it is going to be, it's a regular polynomial. Okay, the second thing you have to find is the average rate of change. You remember this guy? So we're going to do f of 2, a rock, minus f of 0, over 2 minus 0. So f of 2, plug in right here. What's 2 squared? 4 minus 2 is 2. 2 cubed is 8. 8 times 5 is 40. So my first term is a 40 minus. Okay, next I'm plugging in 0. What's 0 minus 2? Negative 2 cubed. Negative 8 times 5? Negative 40. So really that's a plus. 40 plus 40 is 80, and 80 divided by 2 is 40. That is my average rate of change. Now, here's what mean value theorem says in case you forgot. Okay, the tangent slope, the derivative, has to equal that number. So what am I going to do? I'm going to take the derivative. I'm going to set it equal to 40. Yeah? So I'm going to put there must exist an x equals c within the interval from 0 to 2 so that f prime of c equals 40. Yeah, and that's why we're reviewing it. I wouldn't expect you to just be like, oh, yes, of course, there must exist a blah, 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 right? It's been a while.
Unless you're Einstein.
True. So there has to be a c on my interval where my derivative is equal to that average. If that's the average slope, my slope had to equal that at least once. So take the derivative for me by hand. What rule are you going to need?
Chain.
Chain rule, very good. So I'm going to set f prime of x equal to 40 and solve. Now, question, where should my answer be on what interval?
0 to 2.
X should be within 0 to 2. So if I get a number outside of that, I don't even want it. I only care about a number in there. So let's take the derivative. F prime of x. Okay, we're going to label it first. What is my core in the middle?
X squared minus 2.
Okay, it was to the third power. When I times that 3, down on that 5 in the front, what's my new coefficient? 15, and what's the overall power?
Squared.
Squared times by derivative of the middle is 2x. Then from there, you can combine the 15 and the 2x to be a what?
30.
So I'd have 30x, x squared minus 2 cubed equal to 40. Now, would you be solving that by hand?
You mean squared.
Oh, I did mean squared, thank you. Okay, would you be solving that by hand? No. How would you solve it in the calculator? One side is y1, one side is y2. Look for where they cross. What interval should you be looking at?
0 to 2.
0 to 2. And remember, if it's cubic, it could hit the same number multiple times. So you may want to restrict your domain. So I'm typing in 40 as my y1, and I'm typing in 30x x squared minus 2 squared. Boom. Just like that. Like y1 and y2, doesn't matter. Okay, now when I adjust my window, I'm going to go from 0 to 2 as I said. Okay, then I go to hit graph and my 40 line never shows up. Why is that?
It's way up there.
Because it's way up at 40, so how do I fix that? Go back to window. I'm going to make my y max. Okay, so your y min is how low it goes. Your y max is how high it goes. I'm going to just make it 50. You can make it higher if you want, but 50 should be good enough because I only really have to see to 40. So there's my 40 line. There's my graph. I'm only considering solutions on the interval. How many are there?
3.
All 3. So all 3 of those could be the C. And then you just find them. Oh, okay, just leave your calculators on your desk. Y'all have a good day. Sorry, I'll start in a second.
She got caught up.
I got caught up in the calc.